Hello and welcome to SAS Junior Math. Today we are going to be looking at the types of angles. And from what we have here, we have acute angle, right angle, obtuse angle, straight angle, reflex angle, complementary angles, and supplementary angles. We are going to be looking at them one after the other. So let's get started. Before we proceed, I want us to really know the basic introduction on angles. Now, let's start from a concept, a geometric concept, which is called ray. What is a ray? A ray has both the features of a segment and a line. A segment has a starting point and an end point. But a line has it's a combination of continuous points. So if I have this point and a line is drawn, so you can see that a line contains or has so many points and they are infinite on both ends. So I can say this is A, B, C, D, E, F, G, H. So I can as well say this is line BC and this is line DE. I can say this is line FE. Now these two arrows, as you can see up here, denote that it is a line that moves continuously on both sides. It's continuous and it's infinite on both ends. So now from here, what do we understand by the word ray? A ray has a beginning point and it goes infinitely in one direction. So it may be in this direction and it may be the other direction. But what matters the most is that for a ray, you will have an end point. It starts with an end point and it goes on in one direction for life. So let's say this is A, this is B, this is C, and I want to represent this. I can say this is ray AC, and I can as well say this is ray AB, but I cannot say this cannot be ray BC. Why? Because the end point is starting with the end point A, not end point B. So I won't say this is ray BC. However, I can say this is ray AC and this is ray AB. Now that we've known what a ray looks like, the combination of rays, let me put it like this, the combination of two rays forms what is called an angle. So if this is a ray and this is another ray, if I combine them, they will have a common endpoint, and this is the common endpoint. So let's say this is ray AB and this is ray BC. AC. So automatically it's just like saying this is ray A, B, C. So now that we've known what a ray is, and we've known that the combination of two rays forms an angle. So from here we move on. So let's move on to the main topic for the day. So now that we've known what an angle is, so it's a combination of two rays and of which they both share a common endpoint. And this space here that it forms, this is the vertex. So this angle, this is what, as in when two rays form or join together, what happens? An angle is formed. Now, how do we name our angles? Now, let's say we have B, and let's say we have A, and let's call this C. We can name our angles in three ways. The first way of naming them, in fact, before I even proceed, there's something I want us to understand here. And that thing is, if you are naming your angle, make sure that the letter that is at the center, that is at the vertex point. This is the vertex point. That is a point where two lines meet. That is called a vertex. So at this letter here, make sure it is always at the center. So I can say this is angle, this is ABC, or I can say this is angle CBA, or I can say this is angle B. However, you can as well say this is angle ABC, angle CBA, and this is angle B. Whichever way you can put it, there's no problem. You can as well say this is angle B. So, whichever way you can, do it. But what matters the most is that make sure that the letter that is at the center will always make sure it is always present at the center. So which means we are focusing more on what? On angle B. That's what this thing means. So now that we've known what angle is, we will now proceed to the types of angles. So what are the types of angles we have here? The first one that we are going to be looking at now is acute angle. Acute angle. Acute angle. So, what do you understand by the word acute angle? An acute angle is an angle that is greater than 0 but less than 90 degrees. So let's do a quick draw on how an acute angle looks like. So I can say this is an acute angle. So this is A, B, C. An acute angle is an angle that is greater than 0 but less than 90 degrees. So if I'm to represent using my inequality symbol, I can say this is 0 less than x less than 90 degrees. Now let me quickly explain this to us. Now what does this statement mean? It means that x is in between, or let me put it like this, that the value of x is in between 0 and 90 degrees. It doesn't really mean that if you want to start your angle, you are going to start from 0 and you end 90 degrees. No, it is in between 0 and 90 degrees, which means that if you want to start plotting your angles, if you want to start measuring, you are going to start from 1, not 0. So if I want to open this automatically, if I say A is less than B, automatically B is greater than A. That's what it means. Let's use figures to represent that, to make it clearer. If I say 3 is less than 7, 3 is less than 7, then automatically 7 is greater than 3. Can you see it now? 3 is less than 7, automatically 7 is greater than 3. So if I say 0 is less than x, automatically x is greater than 0. So that's what it means. So if I were to do this, if I were to follow the definition of an acute angle, I would say x is greater than 0 but less than 90 degrees. Now, as you can see that the inequality signs differ. That is, x is greater than 0, x is less than 90 degrees. So if I want to arrange it in the right way so that the angles can follow the right direction, then I can as well switch this to be 0. If x is greater than 0, automatically x will be what? Less than. So it's going to be 0. See? X is greater than 0. So I've switched it the other way around. So it's going to be 0 less than x less than 90 degrees. So let me take this again. An acute angle is an angle that is in between 0 and 90 degrees, meaning that it's going to start from 1 to 89. It's not going to end at 90. It's going to start at 89. From 1 to 89. So it means that the angle is in between 0 and 90, meaning that it's going to start from 1 and it's going to end at 89. So we'll move on to the next angle, which is a right angle triangle. A right angle triangle. So a right angle triangle is always like this. So if this is A and this is B and this is C, automatically I can say my right angle is always 90 degrees. So I can say my angle B is always equal to 90 degrees. That is my right angle. Then the third one is my obtuse angle. My obtuse angle is, this is an angle. So let's say this is A and B and this is my C. So automatically I will say 90 degrees less than X less than 180 degrees. What does this mean? It means that these values of X is going to be between 90 degrees and 180 degrees. Take note, it is not going to start from 90, rather it's going to start from 91 to 179. Let's not forget that 90 is less than X. Here means that X is greater than 90 degrees. But in order for the inequality symbol to match, that is why we have to swap by changing the position in such a way that it's going to be 90 less than X, because if 90 is less than X, automatically X is going to be greater, X is greater than what? 90, from the rule I gave the other time. So let's not forget that the values of X is going to be starting from 91 to 179. From 91 to 179 degrees. So what happens here is that so far it is greater than 90 degrees, then we can call that an obtuse angle. Then from there, we'll move on to a straight line or a straight angle. A straight angle is equal to 180 degrees. So I'll say this is X equals 180 degrees. So a straight line is always equal to 180 degrees. And I can as well say, let's use this pattern, that if a revolution or a circle is 360 degrees and I split it into two parts, it means that here will be what? 180 degrees, and here will be what? 180 degrees. Now let's assume that this one is not there. So can you now see that a straight line will always give us 180 degrees? Then we'll move on to reflex. A reflex angle is an angle that is greater than 180 but less than 360. That is 180 degrees less than X less than 360 degrees. So this is an obtuse, is a right angle. This is an obtuse angle, and this is a straight angle. Then this is a reflex angle. So a reflex angle is in between 180 degrees and 360 degrees. What does it mean? It means that if we want to start getting the values of our X, we are not going to start from 180 degrees. Instead, we are going to be starting from 181 degrees to um, to 359 degrees. So that's what it means. So from 180 to, so it means that you're going to start it from 181 degrees to 359 degrees. So that is the values of x for reflex angle. So then from there we'll move on to complementary and supplementary angles. Complementary angles and supplementary angles. Now, a complementary angle is an angle whereby the sum of its angles equals 90 degrees. So let's say this is A, B, C, and let's call this one D. Now, this is angle 1 and this is angle 2. So, angle 1 plus angle 2 must be equal to 90 degrees. This is the definition of a complementary angle. Now, let's quickly look at this. So, angle 1 can be, let's look at it that angle 1 is from here to this place. So, it's going to be A, B, D. Let's not forget that the common vertex here, which is B, has to be at the center, plus angle 2. I can say this is DBC. You can as well say CBD, and I can as well say DBA for angle 1. I may write ABD, and I can as well write DBA, and I can as well write CBD. What matters the most is that make sure that the vertex is always at the center equals 90 degrees. So let's say, and let us see if, and then let us try and solve. So let's say this is x, we don't know, and this is x. And let's say, and let us find out. So which means if ABD plus DBC equals 90, then this is going to be x plus x equals 90 degrees. So we have 2x equals 90 degrees. We divide both sides by 2 in order to make x stand alone. So x equals 45 degrees. So what does it mean? It means that the angle 1 is 45 degrees and angle 2 is what? 45 degrees. And when you add them together, it gives us 90 degrees. And that makes it to be a complementary angle. Then let's round up with supplementary angles. A supplementary angle is the addition of two angles that makes it to be what? 180 degrees. That is, when you add two angles together and it gives us 180 degrees, then we can say it is a what? Supplementary angle. So for example, now we can have, let's say this is 2x, and let's say this is 4x. Let's check it out. Let's look at it now. Let's say this is 2x and this is 4x. It means that the addition of these two angles must give us 180 degrees. So, and that's what makes it a what? A supplementary angle. So, let's say this is angle A, B, and this is angle C. Now, let's say this is angle A, angle B, and this is angle C. So, how do we solve this now? We are going to say, let's say this is angle A, okay, B, C, and this is angle D. So now it's going to be angle ABD plus angle DBC equals 180 degrees, because we know that the sum of angles on a straight line is 180 degrees, and we also know that the addition of two angles on a straight line gives us what is called a supplementary angles. So this is 2x plus 4x equals 180 degrees. So we have 6x equals 180 degrees. Then we divide both sides by 6 in order to find the values of our x. So our x equals 30 degrees. So let's check it out. So let's substitute the value of x and let's see if it fits. So we have 2 into bracket 30 plus 4 into bracket 30. Let's check if it's going to be equal to 180. 2 times 30 is 160 plus 30 times 4 is 120. So, sorry, 2 times 30 is 60 plus 4 times 30 is what? 120, then we have 180 degrees, and that is our right answer. I hope you enjoyed this video. See you in my next video. Thank you.